Environmental Quality Standard for Metals. EQS for metals. Our natural environment is a precious resource that we must safeguard and preserve. To protect and sustain the quality of its surface waters, the European Union has developed the Water Framework Directive, which sets the objective of achieving the good status, both ecological and chemical, of European surface waters. As an essential part of achieving this good status, Member States are required to monitor the concentrations of certain substances in water. The concentrations of these substances, called priority substances and specific pollutants, shall not exceed safe levels known as EQS. However, the setting of proper EQS for metals requires the recognition of specific properties. Indeed, contrary to the most organic substances, metals are naturally present in rivers and lakes, and their toxicity will often be influenced by the chemistry of the surface waters. These metal specificities need to be considered when assessing EQS for metals, and advanced methods exist to do so. This is important for the regulators who wish to meet the water quality objectives. This is also important for industry, as exceeding safe levels may have impacts on the permits. Today we shall introduce the basic principles of setting robust and relevant EQS for metals and explain how to achieve compliance for metals in surface waters. We will address 1. Metals are natural. 2. Principles of bioavailability. 3. Information on bioavailability. 4. Compliance with EQS.
Metals occur naturally in rivers or lakes. Therefore, all life forms in the water are exposed to low concentrations of metals. Normally, these are not harmful to aquatic life, and some essential metals, such as copper and zinc, are even needed by organisms to grow and develop properly, whereas others have no known specific benefits to aquatic organisms. Metals will only be harmful to aquatic life once a specific threshold concentration in rivers or lakes is exceeded. This may be caused by the release of metals from industrial, agricultural, or domestic activities. For compliance checking, not only is it important to calculate accurately above what threshold concentrations metals may become harmful, but also to estimate the low concentrations and non-harmful background concentrations of metals that are present in the water. When they enter natural surface waters, metals will rapidly be distributed to different phases in the water column. Part of the metals will bind to suspended solids present in the water column. It's generally thought that such absorbed metal is not able to interact with the organisms in the water. In other words, this bound fraction is not bioavailable and will consequently not harm aquatic life. The unbound part will remain in solution and is called the dissolved metal fraction. Within this dissolved fraction, metals can be present in different forms that may vary considerably depending on the surface water chemistry. Part of the dissolved metal fraction will be bound to dissolved organic matter, also called dissolved organic carbon, or DOC, or to smaller inorganic molecules such as carbonates. Such dissolved metal complexes are also not bioavailable and therefore not toxic to aquatic life. The remaining unbound part of the dissolved metal fraction in the surface waters consists of free metal ions. This is the bioavailable fraction which can absorb onto the tissues, such as fish gills of organisms, and which can hence cause toxicity to aquatic life. Indeed, the absorption of free metal ions onto tissues can be blocked by the presence of other naturally occurring cations in the surface waters, such as calcium, magnesium, or protons that have the tendency to compete for binding to the same tissues. In such cases, fewer metal ions will absorb into the tissues, meaning that less toxicity can be expected. For this reason, water conditions such as hardness and acidity, or pH, will also define the bioavailable fraction of the metal. To summarize, The bioavailability and toxicity of dissolved metals in natural surface waters will depend on complexation of the dissolved metal to dissolved organic matter or inorganic molecules and competition of the free metal ions with cations such as calcium, magnesium or protons. To be able to predict the bioavailability and toxicity of metals in natural surface waters with different chemistries, user-friendly tools such as Biomet have been developed. Biomet is a freely available web-based tool. As with similar tools, you'll have to input certain information into Biomet in order to get an output. Biomet has the advantage that it requires only a limited amount of information, namely DOC, pH, and calcium data. Based on this input data, Biomet allows users to derive site-specific environmental quality standards for metals such as copper, zinc, and nickel. Or alternatively, based on the same pH, DOC, calcium, and the measured dissolved concentrations of copper, nickel, and zinc, you could estimate the bioavailable metal concentrations for copper, nickel, and zinc. These bioavailable metal concentrations, or EQS, will be used to assess your compliance. Compliance checking requires proper measurement of both the water quality parameters affecting the bioavailability of metals and the dissolved metal concentration in the surface water. It must be emphasized that checking compliance with the metal environmental quality standards necessitates comparison with measured dissolved metal concentrations in surface waters. Total metal concentrations should not be used for checking compliance. It's emphasized further that a proper measurement of the dissolved metal concentration in surface waters requires the use of appropriate methods and quality assurance measures to prevent contamination during sampling and sample handling.
The most common causes of sample contamination during sample collection include poor sample handling techniques, input from atmospheric sources, inadequately cleaned equipment, and use of equipment constructed of materials inappropriate for metal analysis. Field personnel should therefore be well trained in the implementation of good field practices. Important measures to be implemented include use of rigorously cleaned material, field rinsing of equipment used to collect samples, proper handling of equipment and samples, routine collection of samples for quality control, and routine inclusion of blanks.
Once the dissolved metals concentrations have been measured, you can start checking whether you're compliant with the EQS for your metals. The following tiered or stepwise approach is recommended. First, as a first tier, compliance is checked by comparing the measured dissolved metal concentrations in surface waters with the generic EQS for metals as listed in the EU directive or in the national lists of specific pollutants. Such generic EQS have been set to reflect conditions of maximum bioavailability and are therefore protective for all fresh waters. The analysis of the water quality parameters, pH, DOC and calcium, is not required at the first tier. Compliance with the first tier is achieved in cases where the measured dissolved metal concentration is lower than the generic EQS that's been set. Sites or samples failing at this tier progress to the second tier. In this second tier, information on additional supporting water quality parameters, pH, DOC and calcium, is required as input in order to calculate the bioavailable EQS or the metal's bioavailable concentrations. Please note that for most metals, DOC is the key parameter that influences bioavailability. Therefore, we strongly recommend that you implement routine DOC monitoring. In this second tier, the dissolved metal concentration is compared with the site-specific bioavailable EQS. Or alternatively, you can check compliance by comparing the bioavailable metal concentrations with the generic EQS. Compliance is achieved in cases where the bioavailable metal concentration is lower than the generic EQS. In cases of non-compliance after bioavailability correction, we would advise to further refine the assessment. For example, you may need to consider the effect of the local natural metal background concentrations on compliance. A program of measures to mitigate the situation within a cost-benefit framework may be required in case of further failure of a site to achieve good chemical status.
Environmental Quality Standards, or EQS, help us to preserve our natural environment. Metals, which occur naturally in our environment, will only be harmful to aquatic life once a threshold is exceeded. This threshold, also named EQS, is influenced by the chemistry of the surface water. The consideration of metals' bioavailability allows us to set robust and relevant threshold levels for metals. To check compliance with the metal EQS, you will need to measure the dissolved metals concentrations in a first tier, and then potentially DOC, pH and calcium concentrations in a second tier. We hope that this short introduction will help you to achieve accurate and reliable assessments, which will contribute to the efficient protection of natural waters, this precious resource that we all share.